Welcome to the Infill Podcast, where we interview the most interesting members of the 3D printing and maker communities, live and with audience participation. And now, here is your host, Jonathan Levy.
Greetings and welcome back, everyone. I'm really excited about today's episode. Before we get started and I introduce our guest, though, we do need to thank this episode's sponsor in one of my favorite segments, which is called What's Printing, Jonathan? Brought to you by Octo Everywhere. As you can see, right now I'm not printing really anything on any of these printers that I can show you. But what's cool about Octo Everywhere and what I've been playing around with a lot recently is the ability to print directly from Slicer for pretty much all of your printers, no matter where you are. So here's something really cool I want to show you guys. Octo Everywhere just added Elegoo Centauri Carbon capability, and I got an Elegoo Centauri Carbon sent to me at my parents' house. Hold on, let me save this file. That's kind of important. And so what's really cool is if you have family members or friends who you want to help out with their 3D printing, I just print directly to my parents' Elegoo Centauri Carbon, and all they have to do is load and unload the filament. It then shows up in my dashboard on Octo Everywhere, where you can see all my printers, no matter where they are, which is super useful. You get a $25 credit. You can sign up. Your first printer is completely free for life, thanks to Octo Everywhere. On to today's guest. Today we are joined by a good personal friend of mine, which is Edward Borg, who just dropped off the call. So I hope he didn't think the podcast was over. But Edward is from Thought3D. You probably know them as the makers of Magigoo, but they also own a company called DryWise. Magigoo, as you know, is one of the top 3D printing adhesives used for build plate adhesion, and DryWise is a inline filament dryer, I suppose you would call it, for engineering grade materials. These are products that I've used for quite some time on the channel, and Edward has become a personal friend over the years. Also, full disclosure, they do support the channel, but that won't influence our interview at all. Welcome.
Thanks.
Sorry
for this,
my friend. No worries. We'll cut it out in post. So I did a whole setup for you and introed you, and welcome to the show. Tell us a little bit about yourself, background, as I get kind of reoriented and back into my flow. When did you get into 3D printing?
So my background is in engineering. I studied electronics engineering, then I started working in software programming. And in 2014, together with my buddy Keith, we started having all these ideas flowing, and we said we tried to create something. We were both scuba divers at the time, so the first idea that sprang to mind was something related to scuba diving, and we wanted to make it safer. So we had this idea of creating a watch that tells you where your scuba buddy is at all times. And it was a huge challenge trying to create this with hand tools, which we had at the time. And that's how we came across 3D printing. When we discovered it, it was still very much in its infancy. So this is 2014 still. The patents had just expired. MakerBot was this big company at the moment. There's all this riprap going around. And Filament producers weren't as plentiful as they are today. So there was this Filament Filaduder, I think it was called, where you're trying to build your own filament extruder. And this is kind of how it started. And we had this idea of creating this filament extruder, and then we'll sell this. But eventually it costed so much to do, and the swearing, I cannot tell you how much. And one thing led to another. Eventually, we built our own printer. We were developing our own 3D printer as well. Electronics, anything, you name it. Somehow we came across, we had this issue of adhesion, so we started solving that. And that's how our first product eventually came about.
Very interesting. So at the time, I imagine people were printing a lot of ABS back in the early days, less PLA and stuff like that.
Yeah.
And one of the things that we talked about is when we had the 3D LAC guys on, is that 3D printing, like the standard 3D printing materials have gotten better. Like people are printing more PLA now and more PETG,
Yeah.
but then the bar has moved because then people will always experiment with more exotic materials. Do you find most people, do you have any information on what your customers are buying? Because you guys also, I think, as a differentiator from 3D LAC, you have like the high end stuff like Ultra Fuse, and you have a product for Peak. I'm interested what the mix of products sold and what your customers are printing with Magigoo.
So, I mean, the biggest market is obviously still PLA and PETG, so the easier plastics. But we see a lot of nylon catching up. Polycarbonate is sometimes used. And high temperature materials, they are being used, but it's mostly, I think, labs and high end, high grade, for example, I don't know, automotive, for example, would use a lot of high temperature materials, mostly for
Right.
testing.
I get the impression that, I get the impression that you guys have a large customer, like what's it called, B2B customer base, that a lot of like print farms, engineering situations use Magigoo as just cheap insurance, especially when they're using expensive materials.
Correct. I mean, we don't have the exact data of what kind of users we're getting because we do most of our business through resellers and distributors.
Right.
So some of this data is hidden from us, but we do get requests for safety data sheets from some of the biggest printing services or not printing companies, but companies across the globe.
That's interesting. Yeah, I use it as cheap insurance. I mean, even if I know PETG is, I'm not going to have bed adhesion issues. For me, it's my time and hassle are worth more than, whatever bed adhesion product costs, right? It's like failed prints are just annoying and frustrating and can damage my printers. I'm curious about the development. Yeah, go ahead.
So, I mean, as you're saying, like it's cheap and easy insurance. But one thing kind of we don't probably emphasize enough is also like for the release of the print. So with some materials, as you know, they tend to stick too much. And we've damaged sometimes during our testing, for example, because obviously we do lots of testing with and without Magigoo, comparing to other competitors. And when we're not using Magigoo, we've ruined numerous sheets. So
right, that's true too. I wonder how much you can tell us about the development process of Magigoo on the note of testing, because I mean, it's one thing to have a product for PA. It's another thing to have like ABS. People always say, oh, you could use ABS slurry. It's another thing to develop a product, and now two products, because you have the Magigoo generic and you have the new Super Grip, which work around a long litany of plastics, right? Like I always tell people when they ask me in the comments, like, if you don't want to spend, a couple $100 buying every possible one or whatever it is, $100, the generic Magigoo will kind of work for everything, and Super Grip I think kind of works, or Super Grip you guys call it.
Super Grip
kind of works for everything, and so I know that's a little bit of the secret sauce, and your partner is actually a chemist, but I think it's very interesting for people to understand, like, how do you formulate something like that? Like, is it kind of like a multivitamin, right? Where you put like, oh, this is if they print PLA, it won't work for PETG. This is if they print PET, like, is it multiple things, or is it one ingredient that just works with everything? Tell me more about that.
No, it's multiple things, but it's different from like having a base which works for PLA and a base which works for PETG and putting them together and hoping that it will work. So it's a mix of chemicals, that some chemicals will stick, some chemicals will release, some chemicals are reactive to the temperature, some are don't. So it's basically this kind of mix that obviously through experience as well. So you're mixing all these chemicals, and then it's a lot of testing. So we go through loads of materials, different materials from different manufacturers. We test them on multiple printers, multiple print sheets. At some points, like even just the matrix of tests that need to be done is overwhelming.
Now, when you say chemicals, are we talking like plastics? Or are we talking, I mean, stop me because I'm not trying to get trade secrets here. I just generally think it's very interesting because, many people don't realize like traditional normal glue stick, that's a form of plastic, right?
Yeah, polymers. Yeah.
PVB, or it's PVB, but there's two different PVBs,
So
which is,
the most common are PVA, PVP, and mixes of those basically.
right. So they're basically plastics with a little bit of water. Whereas here, I get the impression, especially with the more exotic stuff, that just plastic dissolved in a solvent is not going to cut it. So these are like kind of unique chemicals that interact with the plastic, I imagine.
Yeah, so you have different kind of chemicals. Again, like you have polymers, mostly polymers. It's a polymer adhesive, and you're mixing some for stickiness, some for the flow, some for the correct viscosity. It's some complex chemistry for sure, but once you get the hang of it, then it's easier to do.
Yeah, it's super interesting to me. I would love to talk about this at length, but I imagine there's a lot of secret sauce there. The releasing thing is very interesting though. Like recently YouTube has targeted me for like print farm content. And it's just showing me like all these release plates and all the like angling and all the bed swapping. And, it's very interesting. Like coming up with something that releases at high temperature makes it so much easier to just tilt the printer in a print farm situation and, let the prints come off. Do you see a lot of people using Magigoo for that?
I mean, again, like for example, Magigoo Metal was specifically developed with BASF so that it releases the part, because as you know, the green part is very brittle. And the fact that it was also water soluble, even if it stays a bit stuck, it's just spraying a bit of water around it and immediately it releases. So, I mean, definitely it has its own kind of niche spot again, but we're seeing like people using it just for the release as well.
Yeah, that's really interesting. It's really interesting. Do you guys see a threat to your business with all these like super tack plates coming out now and more people using these like high grip plates?
Yeah, for sure. I mean, obviously, the more competition there is, the more noise there is, the more people are going to be hesitant to buy yet another product. So they might have bought the plates. What we've seen from our testing is that these plates do work, but eventually they degrade. So you have a layer on the plate, which is usually PEI or some kind of other coating. And as you're removing prints, this tends to degrade. So you might get 10 prints, you might get 100 prints, which don't work. But eventually this will eat out, basically. And you still need to either apply Magigoo or replace the plate.
I kind of think of it as like activated charcoal, because as I understand it, the way those plates are working is they just have a really high surface area because the texture is like activated charcoal in a sense. And then at a certain point, I think it's not that you're taking plastic away. I think it's you're depositing, little bits are getting stuck, kind of like Velcro, right? If you do Velcro 5,000 times, eventually you're going to, and that's why it degrades.
It depends on which plates, because as you know, there's the smooth surfaces, and then there's the rough surfaces, which would actually degrade, as you're saying. So you're depositing the plastic there, and eventually it's not getting out. So what people tend to do is then scrub them or rinse them really well, but eventually they're still going to be, the performance is going to degrade. And most of the time they're only good for PETG or PLA maybe.
Right.
And still, if you want to print with nylon or with PC, eventually this is going to warp. With Magigoo, we've seen like the plate itself lifting off from the magnets, but we rarely see any warping. So
it's funny that you say that, because I experimented with one of these plates and printing, either ABS or ASA or nylon, a higher temp material. And I think, interestingly, it curled up because the heat, it didn't like the heat. Like, it didn't like being taken above 70 or 75, which I think is why they say, like, lower your temperatures. But also, I think what they're doing is because it's so textured, the amount of steel is less on the plate so that it still meets the same dimension, but you have two sides that are textured. And even if it's, 0.1 millimeters, that's still on both sides, 0.2 millimeters, that's significantly less steel. And so the magnets just weren't holding it, which I thought was very interesting. Nadir has a good question, which is, can you use Magigoo on these kinds of new plates to extend their lifespan?
Yeah.
Oh, that's interesting.
Yeah, in fact, that's why Supergrip was developed. It was specifically developed for these flex plates, and it should work on a huge variety of flex plates.
That's interesting. I thought you would say that it doesn't really get into all the little nooks and crannies. But I guess it's liquid, so why not? But I imagine it destroys those applicators because it's like sandpaper, right?
Yeah, those do get eaten up quite quickly, especially with some of the most aggressive ones. Like lately, we've had an Aligo plate, which is like really rough.
Yeah. I imagine it's not hard, though, to ship extras or sell extras of those.
Yeah, exactly. So we do, if someone has a bottle which is still pretty much full and the nib isn't good enough, just get in touch and we send some replacements.
Yeah. Might be cool to add like a, 3-pack of the extra nibs on the website just so people buy them. I'm the kind of person, and I think a lot of people in 3D printing are, where it's like, I think you're probably this way too because you're in Malta. It's like, for me, it's not a one-day Amazon Prime thing, right? It's like, I dig my wells before I'm thirsty. I buy 3 of everything just in case, because it's going to be like 3 weeks to get it here.
Yeah.
So if I see like, spare blades for the ultrasonic cutter, I'm like, yeah, I'm just going to buy them now, before I need them. I'm interested to talk a little bit about DryWise as well, which you have. I'll show your camera angle. It is this big orange and black box, which is an inline filament dryer. And I'm interested to hear about the development process of it, the use cases. What filaments did you guys have in mind? And what were the challenges in developing it? Because no one else has done this. This is, I think, the first in the industry where it actually will take wet filament and dry it in the time that it takes to get to the printer, right? So a meter or whatever.
Yeah, so we've had the idea for a long time of having this dryer, but eventually when we were developing Magigoo nylon, for example, being in Malta, which is an island surrounded by the sea, so RH here, relative humidity is usually like 75-80% at all times. So we've had to develop Magigoo nylon whilst going with the filament to the oven, getting it back, back again to the oven. So it was quite a nightmare, and it's like there's got to be a better solution, but we didn't find anything better than that at the time. And then in 2019, like COVID times, we had probably a bit more time on our hands. And that's when we started with the first prototypes. So initially we thought we could have like a very small device, but it took much more to dry the filament. So you cannot, there was something on the market which was like literally this small, but it was just an E3D hot end with the filament passing through and the fan, and obviously it did nothing to dry your filament. And we were thinking maybe it could be something like 15 centimeters or 10 centimeters, but obviously it didn't work. So we've had to increase the size. As you say, there was innumerable challenges, and at some point you also the industry was saying it shouldn't work, it couldn't work, so you kind of also doubt yourself at some point. But we're not the kind of people to give up, so we took the challenge and eventually we have it.
The idea is so simple, right? It's like I have water, I run it through, and I heat it up just the right amount for it's kind of, if you think about it, it's like those belt toasters, right?
Yeah.
Which
Or
work for toasting bread.
I like to say like an inline water heater versus
Yeah,
a geyser kind of.
right. But you have to get the temperature and timing exactly right. And the problem is you have those two variables, right? Temperature and time. And you don't control the time. The printer controls the time.
Yeah.
And it's also not consistent, right? Like if I'm doing perimeters, it's going to go much faster. And then if I do infill every 3 layers, then it's going to all of a sudden take more filament and then slow down. If I have a detailed
Right.
layer, it's going to slow down. So you run this actually very real risk of the filament getting stuck at if you have a part that goes up and like that, the filament will get stuck for a few seconds and that could melt the filament and then cause this gooey mess all the way through.
Yeah. Yeah. So that's one of the challenges. Then you obviously have the extra resistance that comes, especially when you're printing with larger spools, where obviously if you're heating up the filament, it quickly becomes stretchable, and obviously you don't want this. So that's kind of when we started. I mean, that was one of the issues that we were having. So like designing the inner parts, creating custom components,
Wow.
getting these machined, like
It's a
yeah,
lot. And
the first prototypes were just like trying to get parts off the shelf and making those work, but obviously it wasn't that easy.
And I've noticed you guys use a lot of, even for production, which I love, you guys use a lot of MJF nylon 3D printed parts, which to me, I have to say, like, when I see a 3D printing company do that, now I've been critical of companies using like, I didn't like when the Prusa XL came with FDM 3D printed normal PETG parts, but when I see companies using like professional grade 3D printing parts, I think it's awesome. I love it because it's walking the walk, right? I mean, so
Yeah,
is FDM, but
I mean, it's obviously something that we knew how to do, like designing the parts for 3D printing. And since like we were just launching the product, the volumes aren't as big, so creating some custom molds or something like that was out of the question. And apart from that, I mean, even the parts themselves are sometimes too complex to try and design and
right.
manufacture in any other way, basically.
I do think as I try to learn CNC and even I've been playing around with injection molding recently. I actually have an injection mold here that I designed. I think we're very spoiled. If you start with 3D printing, you're so freaking spoiled because there's almost no such thing as like geometry that you can't print. There's very few design considerations besides like supports and strength of orientation, but like undercuts, draft angles, like you don't have to worry about any of this crap. So it really is hard if you're in the world of 3D printing to go back and be like, oh, right. Like talking to Jonathan from Multiboard, he was like, he designed the perfect pegboard according to, his needs. And then after, when it's like, oh, we need to maybe think about injection molding this, it's like a 264 piece mold. Yeah.
Wow.
Yeah. It's intense. So 3D printing definitely spoils us. Do you think, though, that there's any use case where even if the product, expands and becomes more popular, comes down in price, becomes like a mass-produced product, do you think there's a world in where MJF printing or resin printing or even FDM scales up and competes on price, or is it always going to be the case, at least for you guys, where sheet metal and injection molding is just always going to be superior?
I think it depends on the parts and on the use case for sure. Obviously, on the numbers. I mean, when you start hitting certain numbers, then injection molding is hard to beat.
Right.
But
I guess that's fair.
But I mean, if it's something which is just or mostly visual, say, and there's like
the numbers are in the thousands. And I think like FDM, if it's done right, it's
Yeah.
pretty powerful.
Yeah, I haven't had a chance to play around with the MJF because their whole thing, right, is like stack parts in the build plate. I was playing
Yeah.
around with the Form 4L, I think it's called. No, their new MJF thing at Formnext. And their whole thing is like, I mean, they even have like an Unreal Engine 3D thing where it's just like drop 500 of them into the build plate and let it stack them. And, you know, it'll take longer. There's no doubt about that. But the machine itself costs as much as one decently sized injection mold, right? So I think, and I didn't ask how much each part costs. I don't know how much nylon powders cost, but I think we get to a point eventually where if you've got, you know, a complex part like a 3D printer, which has 50 injection molds, or maybe I'm exaggerating, 20 injection molds, some of which are, you know, the Snapmaker U1 has some big ass molds. I think we get to a point where 3D printing on the long run, the full production run, comes out even with injection molding. I don't know.
I think it's definitely interesting, and where we're currently at with 3D printing is definitely something we didn't dream of, like
Totally.
when we started, for sure.
Totally.
And again, as you're saying, like with bamboo, with Snapmaker, I mean, the prices with Lego, it's incredible how much like the prices have dropped, how much the quality has improved. Like
Right.
today, printing something has become so much easier.
Totally. I do think it's interesting to see like you guys and Prusa relying so much more on sheet metal fabrication rather than injection molding. Whereas if you'd made your product in China, maybe not your product specifically because the heat is a thing, right? Heat dissipation, and also it needs to be pretty strong because, as you show,
Yeah.
people are going to put a printer on top of it. But I do think it's interesting. Do you think if you made your product in China, injection molding would be a bigger part of it?
I mean, if we had access to injection molding or we had access to machining, definitely.
Yeah. Let me take a quick moment to thank this episode's main sponsor, which is Soval, makers of the SV08 Max, the SV08, and a bunch of other 3D printers that I use quite a bit, honestly. I'm a big fan of their new SV06. I forget the name. Plus? No, SV06, but it's like the new one. Yeah, this one. But I also use the SV08 Max. I just generally love their printers. One of the reasons I love their printers, though, is they're open source through and through, software and hardware. They talk the talk, they walk the walk. They're a Chinese company, but they're playing ball and they're doing things right. So check them out. There's a link in the description. A lot of people are buying the SV08 for the index that's coming, but also I'm now allowed to say on Reddit, Soval teased an IDEX tool changer, like 2 tool changer upgrade for the SV08. So a lot of people are buying that or looking forward to buying that. Edward, there was one question I asked that I wanted to get clarity on, which is, which types of filaments specifically were you looking at when you designed the DryWise? Like, was it nylons? Was it nylon composites? Or was it stuff above? Because, speaking frankly, to spend 1,800 euros on a filament dryer, and I know eventually prices will probably come down as technology gets better, you're not going to dry $22 PETG in there. Or maybe you are. Maybe your customers are. But I'm curious the business case for it.
Yeah, so firstly, the price has already gone down. So it's now
there we go.
1,500 euros.
All right. Let me
which
show
is
that up on
still
screen for
expensive.
folks. That's fantastic,
Which is-
though. That's, you know, almost
Yeah, and
20% decrease.
And it's been done during a period where everybody is just increasing the prices, not lowering them. So,
Right.
But yeah, I mean, as I said, we developed with nylon in mind, and then we expanded to CFs.
Mm-hmm.
But we were always looking at the higher temperature materials. So initially we weren't sure if we'd be able to do those, but we knew that the hardware was capable of going to those temperatures. I mean, we designed it that way.
Right.
but we hadn't tested it. We didn't have access to all the materials yet, or we didn't have access to the printers as well at the beginning.
Right.
But we've managed to dry Altum, Peak, so all the high temperature stuff. And that's kind of where obviously most of our users are buying the DryWise and focusing on, especially in R&D labs.
Right.
But funnily enough, we've had customers who buy it even just for printing completely in PLA at all times, but they just want to have that consistency.
I guess it's in order for it to make sense now. Again, I'm looking forward to the $300 one, so I can have one on every printer. Because I think my audience knows this, and you know this. We've hung out enough. I'm like the least patient person on the planet. Like there's this one roll of PETG, which seems to be more hygroscopic, and I just don't print it because I'm never going to plan my prints 6 hours in advance, right? I come in the morning, it's like, I want this filament and I want it now. So I imagine though at 1,500 euros, it's one of two things is more expensive to you than your money. One, it's employee labor, right? It's like if my team of 6 engineers who are paid 150,000 euros a year have to sit and wait 4 hours to print a prototype in CF nylon, like that's cost me more than $1,500 in labor of them like standing around the water cooler waiting for the filament to dry. And the second one is the filament, right? A roll of Peak is like 800 euros. If it goes bad, or if I print some of it and it's waterlogged and I end up throwing it into the trash, you could easily waste more than $1,800 in filament a year.
Yeah, that's true. So, I mean, as you mentioned, so we've had like people who obviously value the time and the effort that goes into it. So I might put the filament in the dryer and in a dryer or in an oven and wait like 6 hours, and then it's still a guesswork kind of. Right. So I need to try it out, start the print, see if it actually dried or not, and it will be only too late if I actually figure out that no, 6 hours wasn't enough. So I have to then cancel the print, put it in the oven, wait a bit more, try again. So, I mean, we're obviously eliminating all of that, all the guesswork. Right. And again, like with these high temperature materials, I mean, most of them are quite expensive. Like even PPS-CF, which isn't one of the most expensive, it's still not cheap, or PPA-CF. So there you can quickly like get your money back. Mm-hmm. And obviously, like for impatient people, like I'm just like yourself, so
entrepreneurs, man.
I hate to wait for something to be done. I mean, I want it now, and that's why I appreciate the new printers as well.
Totally.
The high speed is something fascinating. Although, I mean, I don't want to go into it, but obviously when you're printing at high speed, like something else has to suffer. So we've seen like degradation in the part strength and the material itself. So
now here's a question, because it's recently come to light. Someone on Reddit did a very interesting study, and I talked to, I think it was Joel from Polymaker, but I had it confirmed by the Polymaker engineers, which is when you dry filament, it's not that you're restoring it back. Like the plasticizers in certain filaments will degrade when exposed to water. So it is always better to not expose the filament to water in the first place, if possible. And I wonder, for that reason, do you recommend that customers feed the DryWise from a dry box or even a traditional filament dryer just to prevent that degradation?
Yeah, that's obvious, but I mean, then again, like in most filament production, it's first, like when you're producing the filament, it's water cooled. So most of the time when you receive the filament, if it's not dried correctly afterwards, you're going to have to dry it anyways. We definitely recommend.
True. I never thought about that, but you and I have stood on filament production lines together and watched them dousing it with water. I mean, it runs through a bath of water. I never thought about that. Huh.
Yeah, I mean, obviously it's better to treat it correctly, and if you can feed it through a dry box, which obviously has to, one, seal, and secondly has to have good desiccant, otherwise it's not a
Right.
dry box. And if they can feed it through that, obviously it's better. But the advantage of the DryWise as well is that you're respecting more the material. So
True.
with an oven, for example, you're drying it, then you're printing again, and then you're having to dry it again. With
Right.
DryWise, you're just drying it before you're printing, and the rest of the filament hasn't been heat cycled, basically.
Oh, that's interesting. That is very true. You're not kind of, I think of it as kind of like, taking the food, like the leftovers out of and
Yeah,
microwaving the whole thing, then putting
microwave.
it back. Yeah, that can't be good for the filament and the plasticizers because it's not a full heat cycle, but I mean, some of these materials you're drying at 100 C, which can't be
Yeah,
good.
and it's even more complex than that because you have some of the material which is inside the material, inside the spool, basically, which is still getting heated, but there's nowhere for the humidity
Yeah.
to go to, kind of. So it's not drying, but it's getting hot, and at certain temperatures, it's actually absorbing more moisture, possibly.
Wow. That's interesting as well. And I've noticed that, like, I microwave some of my spools often, and you notice that the inner core gets much hotter because there's nowhere for that steam to go. And you end up melting it if you're not very careful, which is why people should probably use a proper filament dryer. I really want to see, and I would love for you guys to do it. And I think this is a advantage you guys have over China because you're in Europe and it would be easier to ship. I really want to see more people developing dry box solutions, like large ones. So, like, if you can see, you can't see because of the tool case, but Big Tree Tech is now doing this filament cabinet, but it's mainly for an AMS. Maybe they're going to turn it into a dry box, but it's also very expensive to ship something like that from China. There are very few people making dry cabinets. One is a Taiwanese company and one is an American company. No one's doing it in Europe. And you got to imagine it. There's an advantage to doing it in Europe rather than shipping a big cabinet around the world. But basically, it needs to be a well-sealed container, which you guys are probably very good at with your experience from DryWise, and a Peltier module. So if you do that, let me know. Because I think so. I have a lot of predictions for 2026, but one of my predictions is that people are going to start experimenting. Like 2025, I think we can all agree people experimented more and more with TPU. TPU became more popular. We got a lot of high flow TPUs. There were some great videos put out about TPU, and people are really getting into printing with TPU. I think 2026, people get into nylons more because it's such an underrated material, and printers have caught up. Bed adhesion solutions have caught up. There are heated chambers. There are, great solutions for printing nylon. But the challenge that's keeping people from doing that is the hygroscopicity.
Yeah.
People need good solutions
Yeah,
for
and
drying and keeping it dry.
especially like in certain countries, because then you have, countries where it's very low RH, which isn't that much of an issue.
Right, but for you and I, it is. And as much as I love our mutual friend Duron and the plastic bags that he makes, the vacuum bags, they're not single use, but they degrade over time as you vacuum them and suck them around the spool, and then that's more plastic in the landfill. Whereas if we had just a dry cabinet, first off, it makes it so much easier, right? Just put the filament in the cabinet rather than having to vacuum bag every time. And I think anyone who has vacuum bags, we all have just like them littered around the floor because I'm lazy. I just leave the filament in the AMS instead, and the desiccant is completely waterlogged. So yeah, I'd like to see someone doing that.
I'm not gonna promise anything because
okay, fair. What are some other product categories that you're excited about, though? Are you guys still excited about innovating with the bed adhesives, or do you feel like you've pretty much conquered that hill and now you're looking into other areas of 3D printing? Because I do think, as with the gold rush, the people who made money and did well were the people selling the tools. I think in this, like the 3D printers are a race to the bottom right now, especially with some of the new stuff coming out. But I think there are a lot of companies doing really well with tools and accessories and things like that.
So obviously, I mean, with Magigoo, we've basically developed probably all the adhesives we could develop. At least at the moment, we don't see any new materials coming out which we're having issues adhering to. But we definitely see a lot of new people coming into the industry who don't actually know about adhesives, who don't know about the issue. And like currently our mission is to actually get the message across to these people that, listen, yes, you can try and hack your way around, but it's easier to just use Magigoo, couple of cents per print, apply it, have a nice print, and keep kind of your mind at ease.
Yeah.
So this is definitely kind of one of our focus areas at the moment. But with regards to R&D, we're seeing, like, as you're mentioning, like these auxiliary products. So we're seeing what issues still lie dormant, kind of.
Right.
And one of them is like part strength as well. So we're trying to get parts which we want to use. But as we're saying, like sometimes it's either the plastic which has degraded, or it's maybe just the print orientation, or it could be like a multitude of things. So we're looking at making parts stronger, be it either as post-processing technique, or maybe that's some software which improves the printing orientation, maybe. So that's one area we're looking at. Obviously, my background being electronics engineering, it's like I always have these ideas of other ancillary products that could, like, either sensors or things like that. But again, there it's quite difficult to compete with someone like BQ, who is obviously much larger in producing those kind of things. So it's trying to find these issues which no one has solved yet.
Yeah. I have another idea, which is someone actually designed this. Basically, someone just needs to mass produce it, but a filament loader. Did you see this print? I ordered the motors. They keep getting stuck in customs, so I don't actually have a working print to show, but like just, and load the printer. God, this would be like on my belt hook, because all day I'm loading and unloading printers, and it's a freaking hassle. I would love to see someone do that properly.
Yeah, so I've seen that, and funnily enough, the first idea we had for the dryer previously was manually, and the printer had to then pull the filament. Now we have the autoloader, and you've tested the first version of it. You should have received now the newer version. But the first idea there was just a simple motor, which is actually just loading the filament. Obviously, in our case, it simply didn't work, because if the filament is somewhat soft, the first resistance it's gonna find, obviously, it's gonna buckle on itself.
Right. Yeah, that's challenging. But I think, oh man, as we get bigger printers, it becomes so much more annoying to load them.
Yeah.
No,
I mean, that's a very cool product, actually.
Yeah, I'm actually really excited about it. If I ever get the motors, I'll get this built. Now, I want to ask, you guys probably do a lot of 3D printing in your product development process. What filaments are you using? What printers are you guys using? I think I see a Creality K1 there, but what else are you guys using in the product development process?
This is my own personal printer. But at the office, so we have like Crealities, we have Magigoo, we have Ultimakers, of course, we have Race 3D, we have all the bamboo printers, we have a whole mix of printers, we have some high temperature printers as well. So obviously it depends on what we're doing, but we print a lot of nylons. So we print nylons obviously as a test print for quality control for each and every dryer that we develop. Okay. And then we use ASA for some of the Magigoo QC, we use nylon for Magigoo QC, obviously PC
for each and every Magigoo, we have to use the specific material. So a lot of our prints, unfortunately, are not nice prints or anything like that. It's mostly like QC prints.
Yeah.
But since we're trying to like do a bit more marketing, we're starting to print a bit more fun stuff as well. And it's something we want to develop more. So, I mean, we're mostly a bunch of engineers, so we're always creating stuff. So it's just trying to now print them and share them with people as well.
So I have a marketing idea for you, which is you should show like a spool in the background of, a few different materials, and then a filled print, like from bed detachment. And it's like peak, and then you show the filled print, and it's like in red, like minus $600. Then you show like PACF filled print minus $400, and then you show someone applying Magigoo in the third pane, and it's like minus $0.02. Such an easy idea, and like so understandable. We do have a question from Andrea Galeazzi from Prussia, who says, I'd love to get that dryer, but I have a concern. What about very wet filaments? Does it break inside?
So obviously it depends on what kind of filament, how brittle it is, but we usually actually start our development process for a profile by putting the spools and actually hydrating them at 70% RH for like until they reach equilibrium. So they're very wet.
Gotcha.
And it's usually the other way around. It's mostly when they are like dry that they're gonna break, unless it's PLA, for example, which is quite brittle when it's wet. But we rarely had filaments breaking inside, and now with the new upgrades in the system, it's very easy to clean it, even if it does break inside, because the whole thing can be screwed open, and you have access to the whole channel basically.
Oh wow, that's the version that came out after the one that I currently have.
No, you should have the latest one with those screw out parts basically.
Oh yeah, the like cable clamps that you can just open. Yeah. Cool. I need to play around with it more. I'm gonna do some PPSTF pretty soon. So is it now approved for, because you're running it on the side, is it now approved for running it like that, or do I need to do some upgrades to be able to run it on its side?
No, you should have no issues running it like this. As long as there's like a bit of space for the airflow to dissipate.
Right. You got to make sure it's on the right side, or on the left side.
On the left side.
I might print some casters and put it on casters, because I think I will get more use out of it if it rolls around. Then again, I'm a unique use case, right? Because I'm printing on new printers like every week. Andrea, thank you for joining the membership. That's awesome. And Andrea says, very interesting, very useful for my farm. I will let him contact you, Edward, because it is interesting. And I want to come out to Malta and check out your operation, though. After you saw how I raided IBOS, you were like, I'm not sure I want you to come if you're going to raid through our stash of dangerous things. But it was really cool hanging out in China. For those who don't know, the video hasn't come out yet, but we spent like a whole day together just laughing and hanging out and bonding about dad stuff and 3D printing. So that was awesome. And I'm assuming I'm going to see you at Formnext.
Correct.
Perfect. All right, my friend. Well, let everyone know. I mean, we're going to put links in the description, but for those listening in the car, where's the best place to pick up Magigoo? Where's the best place to pick up DryWise? And how else can they learn more?
So we have a number of resellers all around the globe, basically, but the best way to find it is maybe going on magigoo.com or drywise.co and seeing which resellers are closer to you, or just send us an email. It's info@magigoo.com or info@drywise.co.
Perfect. All right, my friend. Thanks for coming on the show, and I'll see you in 2 weeks, 2.5 weeks.
Awesome. Thanks for having us.
My pleasure. Take care.
Look forward to hanging out again.
Thanks for tuning in to the Infill Podcast. For show notes or links to anything mentioned in today's episode, visit thenextlayer.com. If you enjoyed the episode, please don't forget to leave us a review wherever you're listening, or click the like button to let us know. And consider subscribing to The Next Layer on YouTube so you can tune in live and participate in the next conversation. We'll see you on The Next Layer.